Okay, class, welcome back. This is kind of a continuation of the backing strip weld test that we did. If we go back, got the part here. This is what we had welded out, and want to just kind of go through a little basic video here of the processes, the steps involved with preparing a test piece like this for a face and root bend. So we're going to go ahead and put this part into the specialty vise here, the Bridgeport mill, and we're going to go ahead and mill off the backing strip. Got a specialty little fixture built here. If you are going to use this machine, a couple things. One, make sure that you have been properly trained. In other words, have you taken the machine shop class already, or have you received training elsewhere? Never use a machine that you have not been trained on. So make sure that you also really tighten down. Make sure that this part is in here very good and very tight. We do not want it to come loose. I am probably not going to remove the material within the backing material within probably a ½ inch of the outside edge, because I won't need to. I'm only going to cut 2 strips out of the middle. So let's go ahead and turn the machine on here. We're not taking massive cuts either. I mean, we could take some pretty heavy cuts if we were using carbide, and we're not. So we're just trying to take small cuts, probably a little bit of coolant on. The other way of doing this is to grind it, and that just takes forever. So I think you'll find this is a very good way of doing it. Again, I mean, how you go about it is up to you. You don't want to, this is an older machine, so this machine is not as rigid as, say, a newer machine would be. Therefore, it's going to have a little bit more play. So it's not going to be able to take the heavy cuts that, say, a newer machine possibly be able to do. But if you've ever ground one of these off before, it's a very slow process, and you will definitely learn to appreciate what this machine can do. Whatever you do, make sure that you do not go down too deep and cut into the base metal. You would not want to do that. I've seen lots of people do that before. They actually cut down too deep, get down into that base metal. You can't grind or mill or do anything that goes down into the base metal. chips. Clean your chips out of the way so you can see what you're doing. And before you know it, you will be down to the base metal. I mean, you don't have to go all the way down to the base metal. I don't recommend that you go flush necessarily. I think that if you get somewhat close, I mean, you're going to have to grind some anyways. So it's not that big of a deal. We just don't want to have to grind a quarter of an inch off. Clean this off, see kind of where we are, and it may not be in there, you know, this plate could bend, and it probably does bend a little bit. That's why we're trying to prevent that. So it might not be perfectly flat, so one side might kind of bottom out and the other side still got a high spot. I think that's going to be deep enough. Just clean it off. Take that layer off. If you've never used this machine or a machine like it, always make sure you receive proper training before trying to use the machine. This machinery can be very powerful and dangerous as well. Okay, so what should this kind of look like? All right, so you know we could have took these off, but there's really no sense. We're going to be cutting down through the middle, and you can kind of see what it looks like. Okay, so moving on with the second step in this process of creating our bend test. So we have just milled off the backing strip. You can see it's gone. I just want to really emphasize not to go down and cut into the base metal. You just got to be extra careful that you don't do that. Here is an example of a part. This is from a student from a few years back. It's got a little rust on it because it's been in my office. But you can see kind of what they were up to here. What their plan was is beyond me. I don't really understand why they went so deep, and the backing strip is still on over here. So please do not do that. you know, this is a perfect example of showing what not to do. The student was actually going to weld this back together and thought that that would work. So yeah, you can't do that. So what we want to do is, I have a square here that this end of it is 1.5 inches wide. Sometimes they have special fixtures made up for this. This plate is only 5 inches wide. So like I talked about in the welding video, if this was a 6-inch wide plate, we would typically come in 3/4 of an inch from each side. Okay, come in 3/4 of an inch, and then we would lay out an 1.5 inch wide strip on each side, and then we're going to actually have a strip in the middle that's 1.5 inch wide. And then that strip in the middle was actually the alternate piece. So you have like a face bend, a root bend, and then your alternate piece. This is not a 6-inch wide piece, and not every test does that. I mean, that isn't a code book, though. That's the way a lot of tests are performed. So I just wanted to throw that out there. But I'm going to just make a line right down, kind of like right down the middle here, and then I'm going to come over on this side of it. Then I'm going to move over to hold this on the center and make a line down that side. And then what we're going to do is basically make 3 cuts total, and we will have our 2 strips that we're looking for. One will be a face bend, one will be a root bend. And you know, a lot of places you go and take a weld test, you don't get to even take part in this. This is something that you do the welding, and when you're done, you hand it to the test supervisor, and your job is done. But in a lot of places, though, you know, for practice and preparation, and even some test facilities, you know, you're supervised, but you do get to prepare, you know, your coupons for bending. So, anyways, that's what we're going to do. The next step is we are going to head over to the plasma track cutter and cut these out. We could flame cut them if we wanted to. That works pretty good, but we've got a plasma track cutter. We'll cut these out. Now, one thing I want to mention is, you know, coming from the Bridgeport milling machine, I was using some coolant on these, and I went and washed this off and kind of cleaned it off a little bit. I just don't want coolant residue when I go to flame cut or plasma cut, just because it's an extra, you know, fume that we don't need around. So anyways, that'll be the next step. Okay, so now we're over at the plasma track cutter, and we are about to cut out our actual test specimens here. I'm going to turn on the ventilation. It's going to get a little bit loud. I recommend that you make a test run back and forth before you actually make the cut, to make sure that you are going to cut on the line that you want to. So, and I like to be pretty much right on the edge when I go to start. And it's kind of you got 2 things you have to do here at the same time. You actually have to make sure that you not only start the plasma, but you also take the track cutter and hit it in the direction that it's supposed to cut. So we're going to go ahead and do this cut. Don't forget to stop the machine. You don't want the machine to keep going, the track cutter to actually go off the end. So I'm going to rotate this part now. That we are where we want to be. power cut right down the middle. Careful, the parts will be extremely hot. A pretty good finish, as you can see, with this process. Okay, we'll move on to grinding next. Okay, now we're moving on to the belt grinder with our parts. We just cut them out on the plasma. So, you know, a lot of times these are going to be stamped. This is an official test. They would stamp, you know, each specimen as a face or a root, and sometimes that happens even, you know, before the weld is made. But what we want to do here is, you know, start cleaning these up. We must clean up the sides anywhere where, you know, there's going to be a bend here. We're going to bend in the middle. This has got to be cleaned up, you know, both sides. And if we're going to do a root bend, then we want to clean up, you know, the root side needs to be completely flat. Then the opposite side, okay, the face, we're just going to kind of knock it down. It doesn't have to be completely flat. We want to leave what we call the toe lines. That way we can see the center of where the weld is. And then on the other part, if that's going to be our face bend, we're going to clean the face off completely flat. And then we'll come around to the back side where the root is, and we will just kind of come in here again and just smooth this off a little bit. We'll definitely hit the sides of everything, and then we're going to radius the corners. We're going to put in about 1/8 of an inch maximum radius on the corners when we bend. One critical thing here is all grinding marks should be running longitudinally, okay, with the specimen. We don't want grinding marks going sideways. A lot of people like to use angle grinders to do this with, and that kind of creates circular radial marks, and a lot of times they're going sideways. When you have marks that are cut in going sideways, that can actually create a stress concentration when you do a bend. So let's go ahead and we'll grind these up, and we will get them prepared to do the bend test. side, this will be our root side. We'll just knock this down. Notice how you can still see those toe lines. Okay, that's probably good enough. Because we're going to bend this side here, the root bend, we're going to radius these corners. There you can see, got a nice little radius on there. That should be good. Let's do the other one. Probably good right there. No reason to go really beyond that. We'll clean up the face. We'll go ahead and put our radius on the corners. Okay, we're down to the last step in doing our weld test specimens here. So we have them all cleaned up good, radiused. All of the grinding marks are going in the direction, okay, of the test specimen. This part here, this is going to be our face bend. This one here, this is going to be our root. Okay, so let's go ahead and get these in here and get them tested. Perform a face bend. The reason we like to leave those toe lines on the back side, we know where we need to be centered, because sometimes that can be a little bit of an issue. On this particular machine, we can actually see how much force that we are applying. That's not that big of a deal as far as bend testing goes. The amount of force that it holds back, it's whether or not the parts hold up, and we'll talk about what's acceptable and what's not here in a second. But this kind of test is a very reliable test. This test is one that puts a lot of strain, puts a lot of force onto the parts. And therefore, some people believe is probably a little bit more accurate than doing an x-ray. Sometimes these get jammed in there. Have to get. Well, we put grease on these and knock this out. We put grease on those because they can and will become difficult to come out. But here I picked the part up. Okay, this first one off of the floor, and as you can see, this one looks like it come out pretty good. Okay, so now let's get set up and unload. Put a little bit more grease on our fixture here, and we do that to try to prevent what just happened. But sometimes that can still happen. Okay, so here we have our root bend, okay, coming up. Go ahead and apply our force, and we'll see what happens. You know, in some cases the root can be the tough one. In other cases the face can be. One thing I will say about this particular test, if you remember back when we did it, I never stopped. I just kept welding non-stop and never give the parts a chance to cool. That's not usually recommended to do, because the inner pass temperatures are going to get much hotter than what they really should, and therefore you overheat the part, you cause sometimes damages internally, metallurgically, to the structure of the metal. So let's see what we end up with here. Oh, this part doesn't want to come out very good either. Okay, get this one cleaned up. Kind of get that grease off of it, and you can see this one looks pretty good. There's like one little tiny mark there. I'm not sure if I hit that, maybe. But what are the specs? So the specs, when we're looking at a bend test like this, we can't have a crack. There can't be any crack on the surface anywhere that exceeds 1/8 of an inch. We can have smaller cracks than 1/8 of an inch, but any crack that's greater than a 32nd, if we add them all up, they cannot exceed 3/8 of an inch total. That would be a fail. Also, corner cracks, you're allowed up to 1/4 of an inch corner crack, provided that there's no visible sign of slag inclusion. If the corner crack exceeds 1/4 of an inch with no visible sign of slag inclusion, that's when we would use that spare alternate piece that I was referring to, that would be in the middle. But if you were doing a test like this one, where we only had 2 pieces, that would warrant, really, the person taking the test could do a redo. It wouldn't necessarily be a fail. So anyways, what we're looking for, bad things. Okay, here's one that was tested earlier. That gives you an idea how things, that's not good. That's a bad day. So kind of unique. I mean, this is why I like to test things. This part was extremely hot. I know I greatly exceeded the inner pass temperatures, and I mean, sometimes you can get away with it. It's just like I was talking about with leaving slag trapped in. Sometimes you can leave it in there and it'll burn out. You'll get away with it, and other times, it's going to cause a discontinuity that turns into a failure. So, anyways, as always, if you have any questions, please don't hesitate to contact me. Thanks, and have a good day.